Welcome to our channel that name is Guruji. We will discuss chapter number 1, that is name real number. In this video we will discuss exercise number 1.3, that is you have to prove a rational number. So what is the definition of the rational number? Rational number, it is the form of P upon Q, and P and Q are integers and Q not equal to 0 and P. So how to solve? Look at this one. Here it is the one question. Prove that root 5 is a rational number. So first of all we will assume that root 5 is a rational number, and this one is our contradiction, and so that's why at last we will write it is the irrational number. So here we will start. Let us assume to the contrary, root 5 is a rational number. Okay, so now let root 5 is equal to A upon B. A and B are co-prime, and B not equal to 0. Okay, let root 5 A upon B, where A and B are co-prime number, and they don't have more than 2 factors, so these are co-prime number. How to solve? Look at this one. Here it is root 5 upon A upon B, so you can write squaring both sides. So root 5 whole square is equal to A square upon B square. So that will be root 5 5 upon A square upon B square. So now you can write B square equal to A square upon 5. Okay, this shows that A square is divisible by 5. So A is divisible by 5 also. Let A equal to 5m. So putting the value of A in equation first. This one is first equation. So you can put 5b square as it is, and A square 5m whole square. So 5b square is equal to 25m square. Okay, so now you can write also 5b square upon 25. It is m square, and 5 banja 5, 5 5 ja 25. So b square upon 5 equal to m square. So similarly you can see here it is same equation, A square upon 5, here it is B square upon 5. So you can write this shows that okay, B square is divisible by 5. So you can write B is divisible by 5. Okay, now A and B both numbers divisible by 5. So they are not co-prime numbers. Our contradiction is wrong. hence root 5 is an irrational number. So it is proved. Okay, so I think you can understand. And next question, prove that 3 plus 2 root 5 is a rational number. In this question we have to prove 3 plus 2 root 5 is a rational number. So let us assume the 3 plus 2 root 5 is a rational number. How to solve? Look at this one. Solution: let us assume to the contrary that 3 plus 2 root 5 is rational number. Okay, so we can write, let this one rational number, so we can write 3 plus 2 root 5 equal to a upon b, where a and b are co-prime and b not equal to 0. Okay, and now you can write 2 root 5 equal to a upon b minus 3. This number is positive, so here it is negative. So root 5 is equal to a upon 2b minus 3 upon 2. Can we write both? You can multiply by 2. So root 5a minus 2b minus 3 upon 2. So you can write here a and b are integers. Okay, so now you can write a upon 2b minus 3 upon 2 is a rational number. Okay, so we can write also, so root 5 is a rational number. Okay, because this portion is rational, so this portion is, both are equal, so it will be also rational number. But root 5 is an irrational number. Okay, this shows that our assumption is wrong. Okay, here it is, root 5 is rational number, and second step, root 5 is an irrational number, so our assumption is wrong. Hence 3 plus 2 root 5 is irrational number. Okay, so it is proved. I think you can understand. Here you can see again, let us assume to the contrary that 3 plus 2 root 5 is a rational number. So that one rational number, so you can show a upon b, and a and b are co-prime numbers. Okay, and 2 root 5, 3 is goes to the right hand side, it will convert into the negative sign. So root 5 equal to a upon 2b or minus 3 upon 2. A and b are integers. Okay, because that was rational numbers, so rational number also integer form. A minus 2b minus 3 upon 2, this portion is rational number, and this rational, so you can say root 5 also rational number. But we know that root 5 is an irrational number, so this shows that our assumption is wrong. Our assumption wrong, rational, this one is not rational, so it will be irrational, so that will be proved. Okay, so we will solve next question. Prove that 1 upon root 2 is a rational number. In this question also we have to prove a rational number. So let us assume 1 upon root 2 is rational number. So we can write, let us assume to the contrary that 1 upon root 2 is a rational number. Okay, so let 1 upon root 2 equal to a upon b. This one is rational number, so we can write a upon b form, where a and b are co-prime and b not equal to 0. Okay, 1 upon root 2, so root 2 is a denominator, so we will multiply by root 2 and root 2, and you can say also rationalization. Okay, so root 2 upon 2 is equal to a upon b. So this number equal to root 2 equals to 2a upon b, right here, since a and b are integers. So 2a upon b is a rational number. Okay, and so we can write this one is a rational number, so it will be also rational number. So you can write here, so root 2 is a rational number. Okay, here but we have root 2 is an irrational number. This shows that our assumption is wrong. Hence 1 upon root 2 is an irrational number, and it is proved. Okay, I think you can understand, and we will revise this one. Here it is 1 upon root 2 is a rational number, so let us assume to contrary that 1 upon root 2 is rational number. It is rational number, so we can write a upon b form, where a and b are co-prime numbers and b not equal to 0. This definition of the rational number. So here it is, we will rationalize the number root 2 upon 2, and 2 goes to this side, so root 2 equal to 2a upon b. Here a and b are integers. Okay, so 2a upon b, this portion is a rational number, this portion is a rational number, and both are equal, so you can say root 2 is a rational number. But we know that root 2 is an irrational number, so this shows that our assumption is wrong. So hence 1 upon root 2 is an irrational number. That will be proved. I think you can understand. If you have any doubt, you can ask in comment section, and thank you very much for watching this video.